Hi, in this episode we're looking at the fourth topic in P2, which is momentum, energy, work and power. So momentum we can think of as being how difficult it is to stop an object. And momentum is worked out by times in the mass times the velocity. Okay, mass we know is measured in kilograms, velocity we know is measured in meters per second, so if we combine those units we get kilogram meters per second. Kilogram meters per second, bit of a clunky unit, but it's just those two combined. Okay, with regards force and changing momentum, we've got force equals the change in momentum divided by the time taken. So we've got kilogram meters per second and we've got seconds. That unit just works out to be in newtons, it's force. So this is going to be really important in a little while when we talk about car safety. Force equals change in momentum divided by time taken. Kinetic energy, slightly more complicated equation. Kinetic energy is half times mass times velocity squared. Velocity squared. It's an energy, so it's measured in joules. GPE stands for gravitational potential energy, and that's equal to mass times the gravitational field strength. Just going to abbreviate that to GravFS just for brevity, and times by height. So mass in kilograms, gravitational field strength in newtons per kilogram, and height in meters. It's an energy, it's measured in joules. There's two equations for work done. Work done equals power times time. So this is like with electrical devices, so the more powerful the device is, and or the more time you leave it on for, power in watts, time in seconds, the more energy is used. Energy again, so it's joules. And the other equation for work done that we're interested in here, work done is force times distance moved. Force in newtons, distance in meters, and work done again is an energy in joules. So one thing that we should know from looking at energy previously is that it can't be created or destroyed, it can only be changed from one form to another. So here, if we've got a simple pendulum, it's held here at the rest position. So if it's held up, what type of energy has it got stored in it? Gravitational potential. So when we let it go, it starts to move. So it accelerates. So that gravitational potential energy turns into what type of energy if it's moving? Kinetic energy. And then, as it goes past the lowest position, goes back up to the other side, it becomes gravitational potential energy again. But it never gets quite as high as it was on the previous swing. So where's that energy gone? It's gone into the surroundings as heat because of air resistance. So the total amount of energy that we put in to start with comes out, is transferred. We never create or destroy it, we just transfer energy from one form to another. Okay, so we're going to have a look at momentum, kinetic energy, work done, and distance here, all for two moving vehicles. So we've got two beautifully drawn vehicles. We've got a truck and we've got a car. The first thing we're going to work out is momentum. Momentum denoted here, P equals M times V, mass times velocity. So for the truck, that equals 2,000 kilograms times 5 meters per second, which gives us 10,000, and that clunky sounding unit, kilogram meters per second. For the car, it's only got half the mass of the truck, but it's moving twice the velocity. So that works out exactly the same. So as we said earlier, momentum depends on mass and velocity. So a bigger mass gives a higher momentum, and a bigger velocity gives a higher momentum. Kinetic energy, remember, is half times mass times velocity squared. So for the truck, that's going to be half, or 0.5, if you're going to put it in on your calculator, 0.5 times the mass times 2,000 times velocity squared. The velocity is 5. 5 times 5 is 25. So the kinetic energy there is 25,000 joules, or 25 kilojoules. For the car, 0.5 times 1,000 kilos times 10 squared. 10 squared is 100. So we get 50,000 joules. So even though the momentum's the same, the kinetic energy is different. The kinetic energy depends more on the velocity than it does on the mass. So in stopping these vehicles, the brakes have to do work. The brakes have to get rid of this energy. So for the truck, the work done is 25,000 joules by the brakes. For the car, the brakes have to do 50,000 joules of work. So if we assume here that the braking distance applied by both vehicles is 100 newtons, we can work out from here, we can work out the distance that they would travel in stopping. So distance is going to be equal to work divided by force. So for the truck, that equals 25,000 divided by 100, and for the car, it's going to equal 50,000 divided by 100. So we get 250 joules, sorry, 250 meters, and we get 500 meters respectively. So this is why speed limits are important. This is why the difference between getting caught a few miles an hour over the speed limit and say 10 or 20 miles an hour over the speed limit is a much bigger deal, because if you add just a little bit of speed, you really severely increase the braking distance. Sorry, the stopping distance. We'll come on to that now. So, stopping distance. How do we define stopping distance? Stopping distance is thinking distance plus braking distance. So what's thinking distance? Thinking distance is the distance covered in the time it takes the driver to react. So say a child runs out into the road in front of you, and between the child running out and you putting the brake pedal on is 0.1 of a second. That is the thinking time, 0.1 of a second. The thinking distance is the distance you cover in that time. Be really careful with that. A lot of people will say the thinking distance is the time taken to react, but we're talking about a distance. The braking distance is much more simple to define. It's the distance travelled while the brakes are on. You might also be asked about factors that affect thinking distance and braking distance. So thinking distance are things to do with the driver, like tiredness, distractions, drink or drugs is often a common one mentioned. So anything to do with the driver, age could come into it, experience, any of that, anything you can think of to do with the driver, those are thinking distance factors. Braking distance are more to do with the car and the conditions, so icy conditions, wet road, old car, worn brakes, worn tyres, those kind of things. Okay, so on from there, we need to have a little think about safety features. So all car safety features are to do with this equation here. So it's the force that does damage to the driver. So in a car crash, whatever momentum the vehicle's got has to be gotten rid of, okay? The momentum has to come down to 0 because ultimately the car stops. So what we want to do to reduce the force is maximise the time taken for this change in momentum. So airbags, crumple zones, seat belts, all increase the time taken, increase time, and therefore reduce the force on the people. That's how all car safety systems work. Okay, good luck with that. See you later.